Let's see, so it's normally distributed. First, every time we hear that word, we should think of this bell-shaped curve. And at the center is always the mean. So they said 14 is the mean. And then 3 units, 3 standard deviations away, so at 11 and 17, this part isn't required, but 3 standard deviations away should be the biggest chunk. That's 67% of your data. Okay, so it's normally distributed. They want the probability that's between 12 and 18 inches in length. So 12 is a little bit less than the mean. 18 is some degree bigger. They want this area under the normal distribution. So we want to find this area because that would be the probability. All the numbers of the normal distribution should add up to 1. So if we just, and so that means it's a 100% chance. If you have anything from 0 to infinity, you've got every option. So the probability should add up to be 1. We want to find the probability of just this chunk here, so that's going to be something less than 1. So to find that, we're going to use the fact that it's normally distributed. We'll convert these to z-scores, and then we can use a z-score to percentile calculator, convert those z-scores to probabilities. Okay, so to convert 18 to a z-score, we use the usual formula. Take the number we're trying to convert, subtract it by the mean, divide by the standard deviation. So that's 8 over 3. Wow, I'm bad at math. That's 4 over 3, sorry, which is approximately 1.333 in our calculator. And then if we do 12, that's going to be negative 2 over 3, which is approximately negative 0.6667. That's enough. And so the old way was to look up this in a table of a huge amount of values. You'd look up the z-score, find out where it intersects with 0.66. That's kind of an outdated way of doing things though, because technology is so just quickly available. I'm just going to type in z-score to percentile calculator. Take the first one that comes up, and then I'm going to type in my first z-score of 1.333 and make sure to check one-sided. Okay, because two-sided would give you the probability between, what do we got? Because z-score of 1.3, they would give you this probability. It would stop here, and that's not the region we want. So just make sure you're checking one side. Two-sided would be helpful sometimes if you're using if you're trying to make a confidence interval too. And so let's use this first result. So 90.8783% of the data are behind our value. So if we color this, if 18 is red, then this is 0.90, just converting the percent to a decimal, 0.908783. So that includes some area that we don't want. We want the area that I shaded in black at the beginning, but that also includes this area. So the way we're going to fix that is by calculating this to a z-score. We'll find this area and subtract the two. That'll leave us with the area in the center. So here's our z-score for 12. We already made that conversion. If we plug in negative 0.16666, sorry, not 1, 0, negative 0.666667. The area to the left is 0.25 as a decimal, 0.252492. So this is 0.2524, forgot the rest, 92. Okay, so the area between would be found by subtracting these two things. So with my calculator, so that's 0.656291, just depends on how many decimals you need. That's the probability of getting a value, getting a fish between those two lengths.